Guys, hope all of us are doing fine. My name is Ernest, and I'd like to welcome all of us to my channel of Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at a definition and the short concept of torque. And this is going to be assisting us in trying to, of course, evaluate the aspect of or the magnitude of a tendency of a force to cause objects to rotate. Now, in this case, we're going to look at this specific aspect of a torque in that particular sense. And I've given these two particular illustrations for A and B in trying to evaluate some of the examples which we are going to come across under this particular concept of a torque. Now, by definition, then therefore, we can give this specific concept of a torque as the tendency to produce what we refer to as a rotational motion. So this is going to be part of the statement whereby if we have an object such as this one, there's going to be a force which is going to be applied on this particular object. So I am going to consider this specific example. So this point is going to be a fixed position which we can give in terms of a P. Now, if we apply, if this particular, of course, object is going to be movable and we apply a force at this specific point, we're going to see that the magnitude of the force which is applied at this specific point is going to be, of course, subject to the distance between the point of action of a force and the fixed position which we are going to consider. So let's give this one the position from P to the point of action of a force given in terms of R. Then therefore we are going to consider the magnitude of this specific force and the distance being given as that, being given in terms of a torque. And this is going to be given in terms of this specific symbol which we are going to give in terms of a tau. And therefore we can give this specific tau in terms of course, an equation which is going to be the product of the force and the distance from this point of action given as such one. And this is going to be a vector quantity which can be given in terms of this specific illustration. And therefore, the magnitude of this particular force and the distance from the axis of a rotation is going to define, of course, this aspect of a torque. And this torque is going to be measured in terms of the standard units for this one of a force, which is a newtons and meters for that specific perpendicular distance from the line of action given in terms of R. Now we can consider these two specific examples which I've given on my right side of the board. And therefore, as we can see, these are going to be nuts being, of course, adjusted using this, of course, kind of an equipment. So in this case, we have given this specific distance from the line of action for the first one given in terms of 80 centimeters. And we're going to see that the force being applied at this particular end is equivalent to 60 newtons. So using this particular relationship, then therefore we can evaluate the concept of the tendency, the magnitude of the tendency to rotate this specific object using the formula which I've just given on the board. So I'm going to look at that one in terms of a question set, which is going to assist us in trying to evaluate these two specific options for A and B. So if a force of 60 newtons, which I've given for A, given as such one, is applied to a spanner to rotate a nut, as shown above, if we are required to find the torque, then therefore we can give it at tau is equivalent to a force times the distance given in that specific case as such one, or as such. So therefore we can evaluate that one by doing a substitution. So we have said that this is going to be 60 newtons times the distance equivalent to 80 divided by 100, and therefore this is going to be forming our meters. And this is going to be equivalent to the value I'm getting 48 newtons meter. So in this case, if we just do this one, it's going to be, let's have a look at this one. So this is going to be 0.8. So basically this is going to be 40. Tau is going to be equivalent to 48 newtons given as such one, Newton meters given as that one. And therefore we can use the same concept in trying to evaluate a B. Now if we try to look at this one, it's going to be forming a different set of components, whereby we're going to see that the force being applied in this case is going to be of a specific characteristic in terms of position as shown. So this force is going to be acting from the line of action using 60 degrees. And therefore, if we try to look at this one in terms of our question set, we will have it given in terms of a 120 Newton force acts at the end of a 10 centimeter range. So in this case, we are going to have this one as our R, which is going to be, of course, this is going to be the distance from the point, fixed point to the, of course, point of action of that particular force. And of course, we're going to be required to find what we refer to as a torque. Now, in this second case, we're going to consider this one as 10 centimeters at the lever arm. So in this case, this is going to be from our lever arm, whereby we're going to see that this is going to be a perpendicular distance from the line of applied force. But we can as well take an alternative case whereby we're going to consider the axis of rotation to the point where the force is applied. And then, of course, we're going to use a component of the force which is going to be perpendicular, of course, to the lever arm. And therefore, it's going to be pertinent for us to extrapolate this specific section. Now, we're going to look at this line of action of a force and extrapolate this one to this particular point. And therefore, that's going to be forming this specific section which is perpendicular to this line of action given as that one. So we shall use our R in terms of this particular point. But from our geometry, this is going to be forming an opposite angle in this particular case. And therefore, we shall have a right triangle being given in that particular section, which is going to be having this specific dimension. So we shall have 60 degrees given as that one. And then this is going to be forming our R. So in this case, we will consider one of the trigonometric functions in assisting us trying to find the ratio for those specific representation, whereby we're going to consider the sine function, which is the sine over 60 degrees is equivalent to, of course, that R all over 10 centimeters. So in this case, we're going to find R in terms of centimeters, which from my evaluation is equivalent to 8.66 centimeters. So kindly do an evaluation in case you find a different figure from your end. You can notify us so that we can do the necessary adjustments. So therefore, from this specific case, having found R and there's a force of 120 newtons, we can find our tau, which is equivalent to a force times the distance, which of course is equivalent to 120 newtons. So me just put it. So this is going to be 120 newtons times the distance, which is 8.66 all over 100 to change it into meters, and this is equivalent to 10.32 newtons. Of course, this is going to be in terms of Newton meters given as such. So from our first case and the second one, we can see that we're going to consider the angle difference from the line of action of a force. And of course, using our geometry, that's going to assist us in trying to treat such a kind of applications which we're going to come across, especially for the nature of forces which are going to be causing a tendency to produce rotational motion, such as the concept of a torque. So kindly check our description boxes for various links of other videos. Subscribe and engage us in the comment section, and also ring that notification bell to be getting updates on our various uploads in math and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.